Good afternoon, sir. Kadit Magdayo. This is topic about the effect of liquid-free surface on vessel stability. When a vessel with a slack, partly full tank rolls of the sea, the liquid in the slack tank moves toward the lower side during its roll, thereby causing the angle of roll and the period of the roll to increase. Because the vessel behaves as if her GM has been reduced, we say the a slack tank causes a vertical imaginary loss of GM. This is called the free surface effect of FCA. The virtual loss of GM can be calculated quite easily and is called free surface correction (VSC) to indicate whether the free surface effect has been applied or not. The GM before subtracting the free surface effects is called solid GM, and after subtracting the free surface effect is called fluid GM. In all stability calculation involving GM, it is fluid GM that is to be used. The free surface effects depends on the length and breadth, mainly breadth of the tank. The volume of liquid in the slack tank has minimal impact. Free surface effect of completely filled tank. When a fluid such as oil, water, etc. filled tank, it remains stationary inside the tank and behaves like a static weight or solid weight. It has no adverse effect on the stability of the vessel, as there is no change in the center of gravity of the ship, as well as the center of gravity is liquid inside the tanks does not change. If no adverse effects on stability of the vessels, as there is no change of the center of gravity of the ship, as well as the center of gravity of liquid inside the tank does not change. Free surface affects the partially filled tank. A partially filled tank, also known as a slack tank, indicates that cargo or water partially fills the tank, allowing it to move freely inside. As the ship hills, the liquid moves toward the lower side of the tank, resulting in a free surface effect. Free surface effect changes the center of gravity of the vessel from G to G1. Effect on stability. Reduction in metacentric height GM. The free surface effect decreases GM, making the vessel stable or more prone the rolling. Loss of righting energy. The vessel's stability to generate righting movement to counteract hailing diminished, increasing the risk of capsizing. Number 3. Increase hailing or leasing. Liquid movement amplifies the rolling of leasing effect when the vessel is submitting to external force. 4. Progressive stability. If the free surface effect occurs in multiple tanks, the cumulative effect can drastically reduce stability, leading to dangerous situations. Factor influencing the free surface effect. Breadth of the tank. Breadth of the tank. Weather tanks increase the free surface effect as the liquid can shift more significantly to level of liquid. The effect is most pronounced with when the tanks are partially filled. Fully filled or empty tanks eliminate the free surface effect. Number 3. Density of liquid. Denser liquid, e.g. fuel oil, generated a greater free surface moment than lighter ones, e.g. free water. Number 4. Ship's motion. Rolling or pitching magnifies the free surface effect by causing more significant liquid movement. 5. Number of location of tanks. Multiple tanks with free surface, especially those located higher in the ship, exacerbate the reduction of instability. Mitigation of the free surface effect. Number 1. Tank management. Minimize partially filled tanks. Prefer fully filled or empty tanks to eliminate free surface movement. Number 2. Compartmentalization. Use longitudinal and transverse buffets within tanks to limit liquid movement. Number 3. Stability calculation. Include free surface corrections in stability calculation for accurate assessments of GM and stability margins. Number 4. Balance management. Proper ballasting ensure the correct distribution of weight and minimize free surface effect in ballast tanks. Number 5. Operational awareness. Monitor liquid levels and vessel stability during loading, unloading, or ballasting operations. Avoid exercise free surface in high tanks or when the vessel already experiencing reduced stability. Consequences of neglecting the free surface effect. Number 1. Reduce safety margins. The vessel becomes more susceptible to capsizing due to reduced stability. Number 2. Difficult maneuverability. Increased hailing makes it harder to handle the ship in adverse weather or during emergency maneuvers. Structural stress. Dynamic liquid movement can exert additional stresses on the ship structure, potentially causing damage. Number 4. Risks of capsizing. Extreme cases of free surface effects, especially combined with external force, can lead to capsizing.